So you should have watched this video, okay, of all of these functions, and you're probably like, why do I need to know them? Well, one, because you're going to be asked a question to list them on your test and quiz. So memorize them. You need to know the functions. You don't have to know the graph. You need to know the function name. Like this.
Okay. I thought you meant like just know the entire function.
You need to know what it looks like. You need to know what's in purple.
Okay, well, we have to know like the reciprocal function is, or just the purple.
You need to know the purple.
Oh.
And obviously what the name is of it.
But like, let's say you forget the purple. If you can say the pink or the red, whatever it was, kind of hard to tell. Then I usually give some credit. But you have, like, this is what I'm asking for, is the actual function.
So you're going to give us a picture and we're going to have to know the function?
No, I'm not going to give you a picture. I'm going to say, list the 12 basic functions.
Oh, okay.
Well, we still have to know the graphs if we, like...
You just said you don't have to know the graph.
No, not, like, as, like, a separate question itself, but I mean, like, in one of the math problems that we do for this section.
You will need to know what they look like in order to be able to answer the questions about them.
That's what I was wondering.
Yes.
Oh gosh, we need to study.
Could we? Like,
This is more of a section of, like, memorizing stuff, not so much math. Like, these questions are going to say, like, the first one we're going to do, which three functions from the graph do not have a domain of all real numbers? Okay, so,
What does that mean?
It means they use...
all right. These are currently just examples, okay, not out of the book, so, yeah, anyways. They're just example questions. They're not actual homework questions yet, but whatever. Y'all know what I'm trying to say. Which three functions from the graph do not have a domain of all real numbers? Okay, so that means there's no gaps, there's no holes, no jump. Vocab needs to go away. This is not vocab class.
F of x equals x.
Okay? Yep, that's going to be one. Or, well, hold on. What? Do not.
I don't know, I'm confused, I guess.
Wouldn't it be... Wait, so it can't be a real number?
Do not have. Oh. That one does have a domain of all real numbers. This says do not have.
Oh!
That's why I was sitting here looking at my answer and I was like, that's definitely one. Why is it not? It's which ones do not. So which ones have a space or a gap? Okay, the square root one. So y is equal to the square root of x.
Where is that?
It's the second one.
And the f of x equals the I and t x. That jumps a lot.
But technically that one is all real numbers because you see how it has a hole but then above it it's filled in?
Okay.
That technically means that value does exist. It's not continuous from last section, but it does have a domain of all real numbers.
So are all these up? So is that the only one?
Nope, there are three of them.
There's
Can you scroll
three.
down a tiny bit?
Is it the cosine of x?
Nope, that would have all real numbers.
Can you scroll down a little bit more?
The absolute value of x?
Oh my, is it f of x equals 1 over x?
Yep, that's one of them. Okay, because remember they don't ever cross this line, so it can never be 0.
Is it the f of x equals ln x?
Yep.
Now I finally
Okay.
understand what's happening.
Doesn't exist over here in the negatives, so
I get it now.
Why wouldn't it be f of
I
x?
kept looking for ones that were.
Why wouldn't it be the one all the way on the right bottom? Yeah.
this one?
Because they cross.
Because it's the x values we're looking at. Domain is x values. So it goes all the way. It's going out to infinity.
I was the one that still kept trying to find one.
Okay, so as far as when you go to study for this stuff, okay, I would look at these questions that we're doing. I would write the questions on a note card, and I would say, like, I would literally write this question on a note card, and then I would memorize which ones are what. Okay, or at least make sure you understand what they all look like if you're not going to memorize their graph. Like, have a decent understanding of them. Okay, because I am going to pull them literally from the ones that we do in the notes and ones you do in the homework. Okay, and then obviously there's going to be some other ones in the homework that we may not cover, but that you need to know. Okay, like I may not assign you all of the odds, but you should at least look at all of them. All right, which function has domain of all real numbers minus 0? So 0 is not part of the domain. Why isn't 0 in the domain for this one then?
Cheese balls. Are you coming up with these examples on your own, or are they in the book?
These aren't like the homework problems, but there are, yes, I think they're in the book. I don't know. Some
What
of the
does
questions
R
are.
mean again? I forgot. I'm sorry.
All real numbers.
Okay.
So this is saying which function, okay, which function, meaning there's one, has a domain of all real numbers but not 0. Okay, so 0 is the only value that's not in the domain.
Oh, that's f of x equals no. F of x equals ln x, right?
No, that one doesn't have.
That one doesn't have negative numbers either.
No.
Would it be?
Could you do f of x equals 1 over 1 plus e?
I'm debating. Is it either the square root function or the greatest integer function?
It can't be the
Either
one
one.
that does not have domain of all real numbers.
Wait, never. You're right. So.
Okay, this one is one that the graph literally touches everything except for x equals 0.
So is it sine?
Cosine of x.
That touches 0.
The one, is there the dot one?
It's literally one that we already listed in the question above.
Oh, it can be one of those?
Yes, is this a completely separate question?
But it says,
Reciprocal
Which is-
function.
which is
The one at.
This one?
Yeah.
Yes.
But that one
What is-
says it
I
can't
was
be a
gonna-
domain. It can't have a domain of all real numbers. But
I don't understand.
Right, this doesn't have a domain of all real numbers. It's all real numbers except for 0.
It says it in the first
Oh.
question. It says does not have a domain of all real numbers, and it's listed in the first one.
Which means
My
by
bad.
doing 1, you should know that 2 has to come from one of the options out of 1. Because every single other function, all 9 other functions, had a domain of all real numbers. Okay? These 3 in question 1 were the only 3 that did not. So then it's all real numbers minus 0. So then you just need to look at which one of these doesn't have 0 in its domain.
This is y isn't 0 in domain.
Okay, so y isn't 0 in the domain.
It just skips it.
What did we talk about yesterday when the
Oh, the
denominator?
denominator can't ever equal 0.
Okay, the denominator can't equal 0. Okay, it would be undefined there because there's a vertical asymptote at x is equal to 0. Okay. So then, another hint, question 3 is going to come from question 1. Which two functions have no negative numbers in the domain?
Square root of x and
1 equals 1 over x.
the ln x.
Oh, never mind.
Okay.
I lied.
Y equals the square root of x and y is equal to the ln of x. Okay. Look at their graphs. Okay, the square root of x starts at 0 and goes out in the positive direction. Okay. The ln of x, where is it? Down here. Starts at 0. Well, it gets really close to 0. It technically doesn't hit 0. Gets really close to 0 and then goes out in the positive direction. Okay, so it never hits the negative. Okay, the 1 over x, where is it? The 1 over x, okay, there are negative numbers. It goes from negative infinity all the way up to get close to 0 but never touches. And then is close to 0 and goes all the way out to positive infinity. Okay? All right, so that was 3 questions about domain. So let's look at one about continuity. Okay, so those were all domain questions. So this next one is going to be a continuity question. Only 2 of the 12 functions have points of discontinuity. Are these points in the domain of the function?
Question. Can you wear these on any day?
It's a sweatshirt, right?
I don't know.
It is a sweatshirt.
Yeah,
Then
just do it
yes.
until someone tells you no.
Yes. I just can't tell for sure, but I'm pretty sure it looks like a sweatshirt.
It's like a cream.
Then yes, it's fine.
So, would this be, okay, I don't know what it's called.
Let's look at let's list the 2 functions first that have discontinuity.
Is it the one with the circle dots? The dots, like, that are over each other? I was trying to
Integer
This
x
one?
Yeah.
Yes, that's one of them.
And then would it also be the reciprocal function? Again, the 1 over x.
Yep.
What is that last one used for most of the time?
Which one?
The last one of the 12.
This one?
Yes.
It's not used a lot, but it's a logistic function.
Okay.
We don't really use it. It's just one of the 12 basic functions, so you just need to know it. All right, so let's look at the reciprocal function first. Okay, what kind of discontinuity does this have? There's jump, removable, infinite.
Wait. Infinite. I don't really know.
Okay, it's infinite. Okay, because it's at 0, there's nowhere that it ever has even a value there. Okay.
The other one's jump.
So this one is infinite discontinuity at x is equal to 0,
What is removable?
but it is continuous at every point in its
I
domain.
don't have enough room to write this.
So it is a continuous function.
I'm not sure how I feel about this.
Okay, most of the time when I ask you questions on the quiz and test, I'm just going to ask you to simply tell me what the 2 functions are. I'm not usually going to ask you what kind of I may ask you what kind, but I'm not going to have you tell me why, if that makes sense. Like, that second part of that question, I'm not going to have you do most of the time. So, okay, the other one, I think Taylor said it's jump, discontinuity. Okay, it's because it looks like stairs. It has the hole, and then right above it, it's filled. And then you go over a little bit, there's a hole, but right above it, it's filled. Okay, so that's jump. If it's removable, it would be something like,
So you know these because they have the word discontinuity in them?
No.
what?
If you look.
I don't understand your question.
I don't know. I don't understand. Let me look at the rest of them before I ask that question.
Okay, so this would be removable. Okay, there's like a spot missing in the function, but somewhere the function is equal to that value. Okay. All right, so this one, jump discontinuity. There's a discontinuity at every integer value of x. Therefore, it's not continuous.
Was Fernald here today?
It If she wasn't, then I need to fix attendance.
I don't think she was.
I don't think she was here.
Okay. I asked and somebody said everybody was here. So, I don't know.
I'm pretty sure she's not here.
I didn't look that close.
I think the fact that
Mm.
that was asked when I wasn't here says that no, not everybody was here.
Everybody was not here. I'm pretty sure Brianna was the only one that wasn't here.
Okay, well, I need to tell the office in a minute. Anyways. Alright, boundedness. Okay, question about that.
No, these ones.
Which 3 of the 12 functions are bounded? Okay, meaning when I say they are bounded, I'm not asking bounded above, I'm not asking bounded below, I'm saying bounded meaning above and below. Okay, so which ones have a max point and a min point? Okay.
F of x equals sine of x, so y equals sine of x, I guess.
Okay. Yeah, you can write f of x or y. I don't care. Just, yeah.
Y equals
Sine of x
cosine
is 1.
of x.
Cosine of x is 1.
Sine of x is 1, I already said that one.
Yep.
And the
Can we do-
logistic function f of x equals 1 over 1 plus e to the minus x, or to the negative x.
Yes. Now let me explain why the logistic function is one of them. Okay. There are asymptotes here. That's what this dotted line means. Okay. That's an asymptote there. It can never go any higher than that. Okay. So it's bounded above by the vertical asymptote, and then there's another one here at 0. Okay. They're horizontal asymptotes. There's another asymptote here. Okay. That is causing it to not be able to go below that value. So that's why it's bounded below. Okay. So it's completely bounded. So we have y equals the sine of x, y equals cosine of x, and y is equal to 1 over, what is it, 1 plus e to the negative x or something like that. That's the one that's forgotten the most, so make sure you look over that one. Or like written incorrectly the most. So
How
just
many more of these are there? Like different
Questions?
No, like categories.
oh, one more. Alright, symmetry. Which 3 functions of the 12 are even?
What do you mean by that?
Thank you.
What do you mean by even? Like just like two.
What function's even?
Okay.
How many are there out there? Alright, I want to guess.
Okay, hold on. Let me make one comment here just as a refresher, okay, because it would have been in your notes for 1.2, but even functions are symmetric with respect to the y-axis.
So y
I have one. Wait, I want to say one.
Okay, well, hold on. Taylor was saying one first.
y equals x squared.
Yes. Y equals x squared.
You
And,
can say 1.
and I'll say the next one.
Never mind. Just forget about it. I don't know.
Y equals absolute value of x.
Y equals absolute value of x.
Is it the cosine of x?
Why is it the cosine of x?
Because it's symmetric. Like they both do the same thing. They both start here and go woo.
Yeah, you could take it and you can literally like flip it over the y-axis and it's going to look the same. Also, another way with that one is I'm pretty sure we talked about in here last year. Briefly, I ran over which trig functions are even and which ones are odd. So that also,
Oh yeah, like the cosine one is odd, right? I think.
No, the cosine is even.
Cosine's
I
even.
mean the sine one is odd. The
cosine
sine
and
is odd.
secant are even, everything else is odd. Okay.
That's what I meant. I meant sine is odd, not cosine. Even though it's just this on the board, see.
I wanted the identity function to be symmetric.
What?
Yeah, F of x equals x with the negative function. Why wouldn't that one use?
Because if you take this and you flip it over, this one's what you're talking about, right? You take it and you flip it over the y-axis, it's gonna do this.
It's gonna make it
And also in the actual equation, if you do the
Yeah, you can
negative
plug in the
x.
negative x thing like we did. And that would also do
other
it
than
for
the
you.
cosine function, I was also looking at that was like x
Yeah,
squared.
that's what I was looking
Absolute value can never be negative.
Yeah, well, an absolute value makes a v, so you take it and you flip it and it still looks the same.
Okay. In other words, if you can do this with it, then it's the same thing.
All right. Would y'all like to have the rest of the time to study? And then we'll do the actual homework stuff on Monday. Okay, that means your quiz is going to be on Wednesday.
at.
That's even better.